I'm one of the ZFS developers, and I'm here to talk about the new ZFS features in Solaris 10 Update 9. One of the first features that I wanted to cover is what we call pool recovery or rewind. It's interesting to think about why pool recovery is something that we went off to develop. Particularly, ZFS is very dependent on the write ordering of or actually the way that writes actually get ordered onto disk. So as a result, if there's anything that ever happens that goes out of order, you end up with a situation where the pool may not be recoverable. And the way that ZFS works is we write out all our data, then metadata, and eventually we write out the Uber block, which is the entry point into the entire pool subsystem. So if we think about the way that writes actually happen, the very last component where the write gets written to is the disk, and on that device there's actually a small amount of memory which is called the write cache. ZFS by default will actually enable that write cache when the entire disk is being used inside the pool. So if you think about when we're actually doing a write, it's quite possible that even though the write has officially completed, it's actually sitting on some kind of memory out on a disk controller, and it's the requirement of the application to go off and actually flush that onto stable storage. ZFS does that on your behalf. So we actually issue what's called a synchronized command, or a synchronized cache command, down to the disk to go off and force whatever in the write cache to be written out to the spinning disk. Unfortunately, there's some devices out there, particularly commodity devices, that don't actually honor that particular command, and they just simply discard it. So you can imagine if you have certain writes that were written to that cache and you take a power outage, it's quite possible that you've lost some particular data. And since there's no particular ordering of the way that things get flushed from the cache on disk to the spinning disk, you are not guaranteed that the write ordering was actually preserved. This may result in a case where after the power outage, if you try to actually import the pool, you'll be unable to, because what may have happened is we may have written out a new version of the Uber block, but potentially the metadata that it points to hasn't been actually written to. One other place where this this out of ordering problem may actually show up is if you're talking about using block device replication, things that like EMC time finder, for example, where you're actually on the back end sending individual blocks from one device to another. So you're shipping them across potentially some WAN and doing this asynchronously. ZFS can't really control the ordering of those particular writes, especially on in an asynchronous mode where they simply might get queued up and sent over sometime later. As a result, you never know the ordering that may have been written to on the destination system. So if you're trying to do something like disaster recovery and potentially end up trying to fail over to the disaster site which you've been replicating to, you may find that the pool on that host may not be importable simply because the data that has been copied over asynchronously is now out of order. And again, you may find that you may have certain pieces of newer metadata which doesn't point to, or points to older metadata, and then you get checksum errors, or for whatever reason we get an I/O error and can't import the pool. So those two reasons alone were enough to cause us to go off and investigate this particular problem and solve it by what we call ZFS Pool Recovery or rewind. So the first thing to note with rewind, in order to make this work, is we have to kind of give a little background on the way that ZFS has structured its Uber blocks on disk. So each label on the device has a region where we maintain 256 Uber blocks. And the way that they work is we simply just round robin and write to each individual one, and after every transaction we just skip to the next version. So over time we'll end up in the situation where we have, we've written 256 and we'll start overlapping from some older regions. The nice thing about this is that as you start, if you realize the fact that we have this ring of Uber blocks, that means that we can actually go back in time and look at the pool state from one of these older versions. You can think of this almost as snapshots for the entire pool. Just as you can snapshot a particular file system and go back in time and look at the contents of that particular snapshot, we can also go back and look at an older Uber block and in a sense get a view of the pool at that point in time and its contents. The problem with that is that we have to do this in a very meticulous manner, simply because it's quite possible that some blocks that the old Uber block might be referring to have now been freed and reused. So if they've been reallocated, it may not be possible to go back very far. As a result, what we've done in order to implement pool recovery is we actually maintain a safety zone where we allow you to have 2 transactions worth of deferred freeze. So any blocks that were freed, you can actually roll back a couple transactions worth and be guaranteed that you have access to all that data. Now, it's still possible to go to rewind the pool even further, but there's no guarantees that you're not going to find cases where some data may have actually been lost as a result of that, as a result of freeing the blocks. So the way that we actually perform this action is we actually start looking at older Uber blocks if you wanted to rewind a pool, and trying to find ones that have valid metadata. And so we are essentially kind of doing like a minimized scrub and looking at all the contents of the pool when you start rewinding back to an older Uber block. So for example, you can imagine that if you were trying to bring in a pool that had some corruption on it, because of either commodity drives, or you were doing this import on a disaster recovery site that was using something like Time Finder, what you would find is that you wouldn't be able to import the most recent, but you might be able to go back a few seconds or even maybe a minute's worth of time back and be able to import the pool at that instance. So you are able to recover the majority of the data that's on ZFS, and it does give you a mechanism to be able to rewind it back to a known state where everything was healthy.